Here we are at CE Engineering Science 201 question 6. Here we have a clock. A clock has an hour hand, a minute hand, and a second hand. And they are all rotating. The hour hand is rotating, the minute hand is rotating, and the second hand is also rotating. But they just rotate with different speed because they use different time to complete one cycle. So we would like to find the ratio of the angular speed. So we are talking about the omega. First of all, I would like you to know that omega is given by theta over t. That means if we are talking about this hour hand, minute hand, and second hand, they all rotate around the clock. So in one cycle, they have the same theta. They rotate for 360 degrees or 2 pi radian. So theta is basically constant for these hands to complete one cycle. The only difference is that they take different time or the period of time that they complete one cycle. So omega is basically inversely proportional to the time. The more time you use to complete one cycle, the slower would be the angular speed. Okay, first of all, let me be clear about everything here. So the second hand, let us consider the second hand. How much time does it need for the second hand to complete one cycle? Think about that. To complete one cycle, a second hand needs 1 minute 60 seconds. So I would call it T as the period for second hand is 60 seconds. Okay. How about the minute hand? I will use different color, easier to see. Minutes hand, I would call it TM. So for the minute hand, each minute it goes a little bit, 1 minute, 2 minutes, 3 minutes, etc. So how long does it take to complete one cycle? Yes, we have 60 minutes. Or if we want, we can change to the standard unit, second. Lastly, for the hour hand. Hour hand, 1 hour it move a little bit, 2 hour, 3 hour, etc. How much time does it need to take for the hour hand to complete one cycle? 24 hour or 12 hour? Okay, so it should be 12 hours. Think about that. It's not 24 because one cycle. So we change it into standard unit. 12 hours times 60 times 60, that is in second. So we now know the period of this hands to go for one cycle. And so we can find the ratio for omega s, that is the angular speeds. Okay, let's start with the hour hand to the minute hand to the second hand. Because omega is inversely proportional to the time, so it will become like this. It will be equal to 1 over th to 1 over tm to 1 over ts. And we can put in the numbers because we all know this. So the period of hour hand is this. And for minute hand, the period is this. For the second hand, we have 1 over 60. Of course, we have to simplify the ratio. We need to multiply the same thing basically we are going to multiply this thing to all the ratios, so it keeps the ratio unchanged. So this will be the answer. This is the ratio of the angular speeds of the hour hand, minute hand, and second hand. So the answer